our day-to-day activities, we tend to fall into patterns. Sometimes we take things for granted and make assumptions. Do you assume that you know how the morning coffee will taste based on how it tasted yesterday and the day before that? When you get to the job site, do you assume the equipment is going to start? After all, it did yesterday. And do you ever assume that just because an excavation didn't cave in yesterday, it won't happen today? Well, that's one assumption that can be deadly. Just ask the family and friends of the 40 to 60 workers who die every year and the more than 1,000 who are injured in trenching and excavation accidents. Almost every trench cave-in happens because someone doesn't follow the simple rules of trenching and shoring. In this video, we're going to look at how you can help avoid becoming the victim of excavation accidents and prevent others from being injured too. This training is designed to help make you familiar with the rules found in the OSHA excavation standard. No matter what your job is, everyone who works at or near an excavation site should have a working knowledge of this standard. We'll start with definitions and a look at the dangers and talk about what to do before excavation begins. We'll also discuss what's meant by the term competent person and what that person's duties are. We'll look at soil classification, protective support systems, general safety practices, and then we'll talk about emergency response procedures. A trench is defined as a narrow excavation made below the surface of the ground. The depth is often greater than its width. Shoring refers to supporting the sides of an excavation to prevent a cave-in. Working in a trench is one of the most common and one of the most dangerous jobs in construction and utility work. Government statistics show that of all trenching and shoring fatalities, 79% occurred in trenches that were less than 15 feet deep. Trenches less than 10 feet deep were the site of 38% of all fatalities.
Well, the biggest safety thing is that everybody goes home safe every night. You know, nobody gets hurt during the day. I mean, being conscious, soil conditions change by the minute, basically, as you're digging.
Some people think that if a trench were to cave in, it would be no big deal as long as it doesn't cover the person's face. But this is dead wrong, and here's why. A cubic foot of soil is not very much, but it weighs about 100 pounds. Just 1 cubic yard of soil weighs about 2,700 pounds, about as much as a mid-sized car. When 3, 4, or more cubic yards of soil press against the human body, there's enough pressure to prevent the lungs from expanding. Suffocation can take place in just a few minutes. Even if the person is quickly rescued, the weight of the soil can cause serious internal injuries. And if the person's face is even partially covered, the chances for survival are slim. The key to avoiding accidents and injuries is to know the proper safety procedures and follow them every time trenching and shoring work is being done.
Before an excavation begins, the person responsible or competent person should look the job site over for extenuating circumstances like power lines, traffic patterns. They should know something about what to expect with the soils, water conditions, so they have the right equipment on the job for the excavation and also for protection of the employees.
Before excavation begins, local utility companies or property owners must be contacted. Most areas have a call before you dig hotline number, so you can find out if there are any underground installations where you plan to dig. These may include underground water and sewer lines, telephone and electrical cables, fuel lines, and storage tanks. Safety above ground must also be established. At the job site, the competent person must inspect the excavation site for large rocks, trees, sidewalks, fire hydrants, overhead power lines, phone cables, and other obstacles. You should also be aware of these hazards. They should be removed or secured so they don't interfere with the excavation work. The OSHA excavation standard refers to someone called a competent person, who's required to inspect the excavation and adjacent areas at least once a day. Of course, this doesn't mean that everyone else at the job site is not competent. It's simply the term for the person who is assigned these responsibilities. The competent person is trained to identify excavation hazards and authorized to stop work if necessary to eliminate those hazards. He or she may also be responsible for coordinating and directing emergency response procedures if needed. At large operations, the competent person could be a full-time safety official who makes recommendations to improve on-the-job safety. At some job sites, a supervisor may be the competent person, as defined by OSHA. At each excavation site, the competent person must inspect for possible cave-ins, potential failures of protective systems and equipment, hazardous atmospheres, and other hazardous conditions. If a hazardous condition exists, it must be corrected before you continue work. For example, if there's a hazardous atmosphere, your company must attempt to ventilate the excavation or provide you with a respirator. Your company's competent person can use a trenching and shoring checklist to inspect your excavation. You should also study this checklist so you can spot hazardous conditions. Immediately before work begins, the type of soil at the job site must be identified. Identifying the soil type helps determine which type of protective system will be used in the trench. This is handled by the competent person, but you should also know how and why it's done because your safety is at stake. Soil and rock must be classified as stable rock, type A, type B, or type C. Stable rock is natural solid mineral matter that can be excavated with vertical sides and will remain intact while exposed. Type A soil has an unconfined compressive strength of 1.5 tons per square foot or greater. This means that type A soil is generally cohesive and stable. Cohesive soil remains in clumps after being excavated. Most types of clay soil are classified as type A.
The unconfined compressive strength of a soil is a property of cohesive soils. It's basically the load per unit area that soil will bear in compression. The stiffer a soil is, the higher the unconfined compressive strength. Moisture content and unconfined compressive strength relate very closely. The higher the moisture content, typically the lower the unconfined compressive strength, and vice versa.
Type B soil has an unconfined compressive strength greater than 1/2 ton per square foot, but less than 1.5 tons per square foot. This means that type B soil is granular and less cohesive than type A. Granular soil breaks up easily and does not stay in clumps. Examples include silt and sandy loam. Type C soil has an unconfined compressive strength of 1/2 ton or less. Examples of type C soil include gravel, sand, submerged soil, and soil with seeping water. To determine the type of soil, the competent person needs to make at least one visual and one manual analysis of the soil. He or she may also take a core soil sample, which may reveal the existence of 2 or more soil types. If there's ever any doubt about the exact soil classification, it should be treated as type C. Sometimes an excavation site contains a combination of soil types. Every location is different. That's why soil classification is so important. There are many factors involved in designing a protective system. Soil classification is just one of them. Others are depth of cut, water content of the soil, changes due to weather and climate, and other operations at the worksite. OSHA requires that in all excavations, employees must be protected from cave-ins by sloping or benching the sides of an excavation, by supporting the sides of an excavation, or by placing a shield between the sides of the excavation and the work area. No matter what type is used, the protective system must meet OSHA performance requirements. There are two circumstances when a protective system is not required. The first is an excavation made in stable rock. The second is an excavation that is less than 5 feet deep. This site must be inspected by the competent person who determines that there is no indication that a possible cave-in will occur. Using the sloping method, the sides of the trench are angled away from the excavation to prevent a cave-in. The benching method uses a series of horizontal levels or steps to keep the walls of the excavation stable. The angle formed by the steps is determined by the soil type. The OSHA excavation standard lists the maximum allowable slopes for all soil classifications. Again, determining the correct soil type and slope is the responsibility of the competent person. But it's your life on the line, so you should know about these rules too. In a stable rock excavation that is less than 20 feet deep, the maximum allowable slope is 90 degrees, which is vertical. In type A soil, the maximum allowable slope for excavations less than 20 feet deep is 53 degrees. This means that for every 3/4 of a foot horizontally, the vertical rise should be no more than 1 foot. By the way, the angle of slope should always be measured from the toe of the trench, which is the outermost edge of the excavation, not from the center. In type B soil, the maximum allowable slope for excavations less than 20 feet deep is 45 degrees, or 1 foot horizontally for every 1 foot vertical rise. For type C soil, the maximum allowable slope for excavations less than 20 feet deep is 34 degrees, or 1.5 feet horizontally for every 1 foot vertical rise. There are a number of exceptions or special cases to the general sloping and benching guidelines. You should read about them in the OSHA excavation standard. For example, for excavations 20 feet deep or less with vertically sided lower portions that are supported or shielded, the support or shield system must extend at least 18 inches above the top of the vertical side. We'll talk more about supports and shields in a moment. When an excavation contains layers of different types of soils, the usual sloping requirements need to be varied. The layered system must be classified according to its weakest layer. The OSHA excavation standard lists sloping requirements for layered soils. Another type of protective support system is a shield. A shield is a structure used in excavation to withstand cave-ins and which will protect workers inside of it. Shields can be permanent structures or portable units moved along as work progresses. Shields used in trenches are usually called trench boxes or a trench shield. Before using a trench box, it should be inspected by the competent person for damage or defects. If it looks like there are any problems, you should report them to your supervisor or the competent person, and the shield should not be used. Several types of shields are manufactured for specific size trenches. Make sure you're using the proper shield. Always follow the manufacturer's guidelines for installing a shield. Overloading the system could lead to a cave-in. No one should ever be inside a shield while it's being installed, removed, or moved vertically. Excavation is permitted below the bottom of the shield, but only to a depth of 2 feet, and only if the shield is designed to resist the forces calculated for the full depth of the trench. There must also be no indication that soil will become loose either from behind or below the bottom of the shield. Although not commonly used today, another type of protective system is shoring. Shoring generally refers to a structure that is built or put in place to support the sides of an excavation to prevent cave-ins. Shoring can be made of timber, aluminum, or other suitable material. Aluminum hydraulic shoring is a pre-engineered shoring system consisting of aluminum hydraulic cylinders used with vertical and horizontal rails. For both timber shoring and aluminum hydraulic shoring systems, there are 4 methods that can be used to design the system. The first uses data from the manufacturer. The second uses OSHA specifications found in the excavation standard. The third method is to use tabulated data approved by an engineer. And the fourth is to have a registered professional engineer design the system. Shoring systems should be installed from the top down. After the excavation is cleared, Remove the protective system from the bottom up, taking care to release members slowly. As soon as work is completed, the excavation should be backfilled as the protective system is dismantled. Here are some general safety practices for excavation work. First of all, know your job responsibilities. If there's a question about the excavation, don't hesitate to ask a supervisor or the competent person. A few minutes of downtime could prevent a serious injury or accident. Make sure you and all your coworkers have and use the proper safety equipment as required by your company policy. These items may include eye and ear protection, a respirator, fall protection equipment, safety shoes or boots, and a hard hat. If the excavation is near traffic, all workers should wear bright warning vests or other garments made of high visibility material. If necessary, a flagger should keep traffic flowing smoothly. A warning system such as barricades, signals, and fences should be in place to identify the location of the trench. If a walkway or bridge crosses a trench and is 6 feet or more above the bottom of the trench, fall protection must be in place, including guardrails and toe boards. No one is permitted under loads handled by lifting or digging equipment. Never work on a slope or a bench above another coworker. This is only allowed after a protective system has been put in place to prevent materials from falling into the trench. Material or equipment must be kept at least 2 feet from the edge to prevent it from falling or rolling into excavations. Otherwise, a retaining device must be used. If the excavation is 4 feet deep or more, an exit must be provided. An exit must be within 25 feet of every worker in the trench. Common types of exits include stairways, ramps, or ladders. If a ladder is used, it must extend at least 3 feet above the landing. Changing conditions can quickly alter the safety of an excavation. If a heavy rainstorm passes through the area, the competent person must inspect the excavation before work resumes. Water can weaken the physical characteristics of a particular soil type. Surface water should never be allowed to enter the trench. If you see standing water in the trench, don't go in there unless adequate precautions have been taken to protect you from hazards created by the water. If anything goes wrong, be ready to act instantly. Be alert for signs of trouble, such as tension cracks in walls, slopes, or ground near the excavation, ground settlement or sinking, changes in wall slope or bulging, spalling or crumbling soil inside the trench, excessive seepage and piping of fine soils, boiling of the trench bottom, creaking or popping sounds, or the bracing system bending and deforming. If you see any of these signs, don't enter the trench. If you're already inside, get out immediately and report the problem to your supervisor or competent person. No one likes to think about an accident, especially in a trench. But you need to know what to do in case something does happen. Rescues can be tricky and dangerous. Don't become a victim yourself by rushing into a collapsed trench before it's stabilized. Your company should have a specific emergency plan to address every type of possible excavation emergency. You should be familiar with this plan because it's the first step toward a quick rescue. Some important points that should be covered in the emergency plan are immediate notification of the authorities and rescue personnel, usually by calling 911, and responsibilities of those working at the accident site before and after the rescue team arrives.
I think one thing people have to keep in mind when they're working in excavations is that soils are a very inconsistent material. So conditions may look good on the surface, but be much worse than that a small distance back from the excavation. These soils are very unreliable as far as how well they stand up.
Working in a trench doesn't have to be a dangerous occupation, as long as everyone knows what the rules are and follows them every day. Excavation work can be done safely and efficiently. So don't assume that someone else is going to take care of following the trenching and shoring rules. You need to do your part too. Know what the rules are, what the hazards look like, and in some cases, what they sound like. That way you can do your part to control or eliminate hazards and keep your job site safe.